The deformer node, as the name implies, allow us to alter and deform the noise map generated by an input node. In this case, I have below input node, and the default deformer node is actually clamping values from -100 to +100. But since these are also the minimum and maximum bounds for INFINITO noise maps, in practice right now the deformer is doing nothing, it's just passing through the input noise map. Let's see the 3D representation of this height map. I'm going to click on Terraform, and as you can see, the terrain generated is hills-like terrain with several terrain depressions. I'm going to get back to the Terraform section, and now I'm going to clamp negative values so that everything that is negative will be set to 0. I'm clicking on this little tiny button which will update my preview, and if I click on Terraform I'm going to see what happens now. And you see, this is what we expected. In practice, all negative values have been set to 0, and so they don't exist anymore. If I get back to the Terraform section, I'm going to do the opposite now. I'm going to clamp positive values. Alright, I'm going to Terraform again, and now you will see how all the values which were positive, higher than 0, have been cut away. Remember that at any time you can just erase a deformer action clicking on this button, which will reset the deformer to the default clamp condition, which pass through all the values from the minimum to the maximum allowed. Okay, and then we have the ABS deformer, which stays for absolute, and the absolute deformer is going to set all values to positive. So what was -1, for example, will be set as +1. And then we have the curve deformer, which contains 16 different profiles. More will come with next INFINITO updates. And each of these profiles allows to create very odd and dramatic terrains. I'm not going to get through each of these. I believe you will be curious to do that yourself. But as you can see, each curve profile will dramatically affect the noise map, and well, the result will be different each time. Then we have the exponent deformer. The exponent is going to amplify our values, our noise map values, and well, it's difficult to explain, but in practice is going to make darker what was dark and make brighter what was light. And so in practice is going to in practice is going to change a bit the scale of our noise map. And then we have I'm going to reset this deformer so that you can see better the next one, which is the invert deformer. Nothing much to explain here. I'm just going to invert values. And we have the round edge, which is very important because it allows to smooth and round our noise map boundaries so that we have a terrain profile which that goes to zero level at its boundaries. We have the scale bias, and also here you will have to experiment to see better yourself what this filter does. The bias is going to smooth our noise map, and well, the scale is going to sharpen our edges. But as I said, these are just filters that need to be experimented by yourself until you find the right combination of the noise maps that you like. Alright, and then we have the terrace. It's quite similar to the curve deformer, and the terrace peculiarity is that it's going to create, as the name says, some nice terraces. And also here there are different profiles that you can experiment. You see now that our terrain has a very smooth look, and well, this is because we didn't apply any turbulence effect yet, and also because we are very low on linearity and persistence. We might perhaps also use some more persistence to get more interesting results. But this will come later, and when we will explore the turbulence section, you will see how things will get even more interesting.